Welcome to the New Physics Project, initiated by Joseph George. Our current understanding of the universe is built upon the foundational frameworks of special relativity, general relativity, and quantum mechanics. However, this project introduces a bold new perspective, that space is permeated by a form of matter continuously generated from mass defects occurring throughout the cosmos. Microscopic analysis of spent nuclear fuel offers both experimental and empirical support for this idea, revealing signs of rapid volumetric expansion, where missing mass appears to transform into a previously unrecognized state of matter. This discovery challenges the fundamental assumptions of relativity and quantum theory, offering alternative explanations for the very phenomena they seek to describe. Rewriting Physics from the Ashes: How Microscopic Analysis of Spent Nuclear Fuel Challenges Our Understanding of Mass and Energy. The microscopic analysis of spent nuclear fuel is quietly provoking a major rethinking in modern physics. Far beyond routine studies of reactor waste, this line of research could append foundational ideas about how nuclear energy is released and what truly happens to the missing mass in fission and fusion reactions. At the heart of this emerging paradigm is a bold proposition, that nuclear reactions generate not only heat and radiation, but also trigger microscopic explosions that transform matter in ways not previously recognized. Rethinking the basics, beyond Einstein's equation. Conventional physics interprets nuclear reactions through the lens of Einstein's famous equation, E=mc². When mass vanishes in a reaction, it is assumed to be completely converted into energy, manifesting as kinetic motion, thermal output, or radiation. In this view, the physical trail ends there. The mass defect leaves no tangible residue beyond damage in the surrounding atomic lattice. However, a new hypothesis, spearheaded by Joseph George, challenges this narrative. Known as the Exploding Mass Defect Hypothesis, EMDH, it suggests that the mass defect is not simply converted into energy but explosively reborn as an ultrafine, space-filling medium, something akin to a modern interpretation of the classical ether. Each nuclear event, according to this view, is a localized microexplosion, leaving behind structural signatures and perhaps even giving rise to a previously unrecognized state of matter. Microscopic clues: what electron microscopy reveals. Thanks to cutting-edge tools like transmission electron microscopy, TEM, and scanning electron microscopy, SEM, researchers can now peer into the atomic architecture of spent fuel rods. The images reveal more than expected. They show radial microcracks, spoke-like fractures that emanate from central points, suggesting sudden, high-energy release rather than slow deformation due to heat. Amorphous zones, localized regions where the normally ordered crystal structure of the material has collapsed into a disordered, glass-like state, evidence of abrupt internal disruption. Deformation patterns, intense, blast-like zones that seem to mark miniature detonation events embedded within the material. These features are consistent across multiple samples and reactor types, making it difficult to dismiss them as anomalies or routine wear and tear. A new interpretation: microexplosions and the birth of matter. The structural patterns found in spent nuclear fuel challenge the idea that energy alone is the end product of mass defect. Instead, proponents of EMDH argue that these patterns are fingerprints of a more complex process, one in which mass transforms into an undetected but pervasive form of matter. This space-filling medium could offer a physical basis for long-standing cosmological puzzles, from the nature of dark matter and dark energy to the mechanisms behind gravitational lensing and cosmic expansion. If this hypothesis holds, it could mean that nuclear reactions generate both energy and a new form of matter. The so-called missing mass doesn't vanish, it transforms and permeates space. Many relativistic effects, currently explained with mathematical abstractions, may arise from interactions with this ultrafine medium. Toward a new physics, implications and future directions. The implications are profound. If these microscopic signatures of explosive mass transformation can be confirmed and replicated, they could initiate a paradigm shift across multiple domains of physics. Key next steps include Experimental verification, rigorous, repeated testing with diverse samples and techniques is essential to establish the reliability of the findings. Theoretical expansion, new models must be developed to describe how mass converts into this hypothesized medium and how it interacts with known forces. Technological potential, if controllable, this phenomenon could inspire revolutionary applications in energy production, materials science, and even space propulsion. Conclusion: a new laboratory for the cosmos. Spent nuclear fuel, long treated as little more than a waste product, may be one of the most promising laboratories for exploring the frontier of physics. Through microscopic analysis, it offers a tangible window into processes that may reshape our understanding of mass, energy, and matter itself. The exploding mass defect hypothesis invites us to revisit the foundations of physical law, not merely to reinterpret them, but to possibly rewrite them. If its predictions hold true, we stand on the threshold of a new physics that could unify nuclear science, cosmology, and relativity under a richer, more materially grounded framework. Revisiting the Ether, a comparative study of classical ether and the newly proposed space-filling matter from mass defects. For centuries, physicists sought to understand what fills the vast emptiness of space. One of the earliest attempts to answer this question came in the form of the ether, a hypothetical medium believed to permeate all space and serve as the carrier of light and forces. Though the ether was ultimately discarded by modern physics, a new interpretation of nuclear phenomena may be reviving the search for a space-filling medium, but in a dramatically different and empirically grounded form. This essay explores the similarities and differences between the classical ether concept and the newly proposed space-filling matter that arises from mass defects during nuclear reactions. The classical ether, a historical overview. The classical ether originated as a philosophical idea in ancient Greece and evolved into a central concept in physics by the 19th century. Physicists such as James Clerk Maxwell and Hendrik Lorentz believed that light, like sound, required a medium through which to propagate. The ether was conceived as an all-pervading, invisible substance, massless and undetectable, yet essential for electromagnetic waves to travel through space. However, as experimental methods improved, the ether model began to falter. The famous Michelson-Morley experiment, 1887, failed to detect any evidence of Earth's motion through such a medium. This null result, along with the rise of Einstein's theory of special relativity in 1905, led to the abandonment of the ether. Relativity eliminated the need for a light-carrying medium by redefining space and time as an integrated fabric, spacetime. A new space-filling medium from mass defects. Fast forward to the 21st century, where a radically different hypothesis has emerged from the study of nuclear fission. Joseph George proposed that the missing mass in nuclear reactions does not vanish into pure energy, as dictated by Einstein's famous equation E=mc². High-energy microexplosions, something not accounted for. High-energy microexplosions, something not accounted for by standard models of heat and radiation damage. Key differences and similarities. While both the classical ether and the newly proposed space-filling matter attempt to explain what fills the vacuum of space, they differ fundamentally in origin, evidence, and theoretical implications. The classical ether was postulated before the development of modern atomic theory and was never supported by experimental evidence. It was a static and hypothetical backdrop for wave propagation, one that could not be measured, interacted with, or modified. By contrast, the space-filling matter from mass defects is dynamically generated in nuclear processes and leaves measurable signatures in physical systems, such as amorphous zones and radial microcracks in spent fuel. The classical ether contradicted special relativity, which eliminated the need for a universal medium. The space-filling matter hypothesis, however, offers a reinterpretation. Rather than denying relativistic effects, it proposes a material explanation for them. Time dilation, length contraction, and even gravitational lensing might result from interactions between matter and this dense, space-filling substance, just as motion through a fluid causes drag and deformation. Moreover, the new hypothesis potentially bridges microphysics and cosmology. If space is filled with matter created during mass-to-energy conversion, then this medium could offer insight into dark energy and provide a material basis for cosmic expansion, phenomena that today are explained primarily through abstract mathematical constructs. A revival, but not a return. In many ways, the space-filling matter concept revives the spirit of the ether idea, a universal medium permeating all space, but it does so with a modern twist. It is not a return to classical physics, but rather a forward-looking reinterpretation grounded in empirical data and consistent with the observed structure of nuclear materials. If validated through rigorous experimentation, this new perspective could reshape our understanding of mass, energy, and the physical vacuum. It invites a new synthesis in physics, where the consequences of mass defect are not just energetic but material, revealing a universe far more filled, structured, and dynamic than previously imagined. Rewriting physics from the ashes, how microscopic analysis of spent nuclear fuel challenges our understanding of mass and energy. The microscopic analysis of spent nuclear fuel is quietly provoking a major rethinking in modern physics. Far beyond routine studies of reactor waste, this line of research could append foundational ideas about how nuclear energy is released and what truly happens to the missing mass in fission and fusion reactions. At the heart of this emerging paradigm is a bold proposition that nuclear reactions generate not only heat and radiation, but also trigger microscopic explosions that transform matter in ways not previously recognized. Rethinking the basics, beyond Einstein's equation. Conventional physics interprets nuclear reactions through the lens of Einstein's famous equation, E=mc². When mass vanishes in a reaction, it is assumed to be completely converted into energy, manifesting as kinetic motion, thermal output, or radiation. In this view, the physical trail ends there. The mass defect leaves no tangible residue beyond damage in the surrounding atomic lattice. However, a new hypothesis, spearheaded by Joseph George, challenges this narrative. Known as the Exploding Mass Defect Hypothesis, EMDH, it suggests that the mass defect is not simply converted into energy but explosively reborn as an ultrafine, space-filling medium, something akin to a modern interpretation of the classical ether. Each nuclear event, according to this view, is a localized microexplosion, leaving behind structural signatures and perhaps even giving rise to a previously unrecognized state of matter. Microscopic clues, what electron microscopy reveals. Thanks to cutting-edge tools like transmission electron microscopy, TEM, and scanning electron microscopy, SEM, researchers can now peer into the atomic architecture of spent fuel rods. The images reveal more than expected. They show radial microcracks, spoke-like fractures that emanate from central points, suggesting sudden, high-energy release rather than slow deformation due to heat. Amorphous zones, localized regions where the normally
I am Joseph George. I am preparing my research paper based on the new hypothesis that mass defect creates energy not because of the conversion of mass into energy as Einstein suggests. Instead, the release of energy associated with the mass defect is due to a change in the state of matter. When a mass defect happens, the missing mass is explosively transformed into a super thin form of matter. In fact, The missing mass creates a volumetric expansion, rapid expansion, and this expansion provides kinetic energy to the reaction products. It has a huge significance in the understanding of the universe. This idea is supported by numerous evidences that we can obtain through the microscopic analysis of spent nuclear fuel. I recently published a book about this, how microscopic analysis of spent nuclear fuel helps to help this hypothesis. The link is provided in the chat box. You can, if you are interested, you can purchase my book. Today, this is the last day. Today also you can download it for free. That is available in Kindle format and paperback format in Amazon. So it was in fact, this study says that space is not empty but filled with a form of matter created by mass defects throughout the universe. This space-filled matter helps to provide better alternative explanation for all phenomena which are we currently study through the lens of special and general relativity and quantum mechanics. All phenomena, Lorentz transformation effects, and other general relativity phenomena such as gravitational lensing, starlight bending, precession of the perihelion of Mercury's orbit, the S2 star orbital anomalies of stars and planets orbiting close the central mass, and many other phenomena can be explained with the help of this space-filled matter. This has a huge significance in the understanding of the universe. There are numerous larger scale mass defects, incidents, events happening throughout the universe continuously. For example, supernova explosions, neutron star collisions, black hole merger. All these events creates mass defects on a large scale, and this mass defects create space-filled form of matter. So this suggests that space is, the entire universe is filled with this super thin form of matter. So we can purchase my book. The book link is provided in the chat box. Thank you for your interest. Thank you for watching.